Was a great presentation and a lot of, I think, good detail, which will flow nicely into this next review, another update that I've done here for this team before around Kubeflow. My name is Josh Bottum, and I work as a Kubeflow Community Product Manager. I've been doing that since the last 3 years, probably the last 12 Kubeflow releases. And really what I'd like to kind of impress on people today is why Kubeflow will help you to iterate faster as you're building machine learning models. Our agenda today is really to talk about some of the market leaders and why they're building their ML platforms on Kubeflow, and then talk a little bit about the user survey results and some benchmarking that you might be able to use. Talk and show how Kubeflow streamlines some ML workflows and simplifies operations. We'll go into a demonstration. And then Kubeflow 1.5, which is our latest release that this came out in March. And then we'll talk about 1.6, which is due in July, and how to get involved in the Kubeflow community. And then I have a slide on the OpenMRM community, which is model risk management. So, you know, a lot of times over the years, we've talked to a lot of people why they should even consider Kubeflow. And really, when as all of us probably have experienced and we're doing machine learning, there's a lot of sprawl, operational sprawl in particular. There's a lot of tools, there's a lot of communities. It can take months of analysis and integration to build, test, and document support practices to have a machine learning platform. And often you end up with some type of custom fork with limited portability between clouds. And there's a lot of tremendous tools out there. Kubeflow, as many of you probably know, was started from an architectural design of being a Kubernetes native machine learning platform. What I really like about it, it has a pretty broad community of shared best practices. It has a tool set for integrated workflows, and allows, because of Kubernetes, portability between different public and private clouds, as well as the Kubernetes efficiencies, which tend to be pretty helpful when you're doing different types of machine learning services. So you can think in the model building here, like if you're building in a Jupyter Notebook, that if you can use namespace isolation, for example, and tie your single sign-on into that, that I could have my own namespace, or I could share one with Jacob, or Jacob could have his own. And that can be valuable, especially with resource limits when you're trying to scale up or do some type of other work inside of your notebook. And distributed training tends to be kind of a nice function too, that is leveraging some of the Kubernetes custom resources. So as you need more resources, you can scale up your training maybe on GPUs and scale back down. Hyperparameter tuning and auto ML, pretty much advanced, but as we heard in the last talk about the search space that you have to deal with the hyperparameters, if you have a nice tool like CatTib, which is part of Kubeflow, that you can automatically just use that in your models. And the nice thing that we saw from when some of the folks from Google came in and presented this one of the first times a few years ago, is they took $1 million Kaggle model and ran it through the hyperparameter optimization tool CatTib, and they improved its performance by 10%, which is kind of funny, right? The analysis, as we saw in the last talk, where using TensorBoard in particular, Kubeflow comes with TensorBoard, so it's we've made it easier to set up TensorBoards and see which ones you have available. Probably besides Notebook, the second most valuable, or let me say the most used component of Kubeflow is the machine learning pipelines Kubeflow pipelines, which allow you to run, these tasks in order and have retry mechanisms and a lot of advanced functionality that helps you. So as you're iterating or new code or new data come in, you're able to build that pipeline quickly, and not to be diminished, but keeping track of the metadata also becomes very cumbersome for folks. And so Kubeflow has MLMD and allows you to keep track of all those hyperparameter tuning and a lot of the hyperparameters and the other metadata associated. And then finally into deployment with the Kserve integration, which based upon both Knative and Istio give you this secure way to do serverless auto scaling. So when you have your model and maybe you have a predictor, a pre-processor that goes to a predictor and then a post-processor, that you can run all of these different services basically on different infrastructure, and it scales up and scales down, scale down being as important. So maybe something needs a GPU for pre-processing and prediction only needs CPU. So you've got a lot of optimization and a way to develop your environment. So the real idea here is that Kubeflow is really designed to provide more models, better business results. And a lot of that, I believe, is from the architecture that helps to reduce the ML sprawl. That said, you do need some Kubernetes expertise. So we've seen many of the market leaders that have been around, LinkedIn, Spotify, Gojek, Intuit, come in and talk about their experiences, and you can see their presentation. They're doubling the effectiveness of their ML engineer. So, I mean, you know how expensive an ML engineer is, how hard they are to find and train. And if you've got a process where you can bring new people in, that's very valuable. Or teams producing 7 times more experiments. It was funny in Spotify, they were like, hey, I think we're getting 5 times more productivity, but that'll probably scare our management. So we're just going to tell them that we're getting 2 times the productivity increase of using Gojek scaling up to 100 million ride hailing jobs. And then Intuit wrote a nice post about advanced orchestration experimentation. A few years ago, I started the first Kubeflow user survey, write all the questions, and I get people to answer it. This time in 2021, we had about 175 people respond, mainly ML engineers, but you also have architects, DevOps engineers, data scientists, right? You'd expect software engineer, but we do see some VPs and some executives and product managers. I always like it when the product management comes in because they kind of give a different view. And then in model life, I think it's important to understand why and how long models stay in production. So here you can see that, some people are replacing their models within a week, some within a month, some within a quarter, but probably 50% are replacing their models within 3 months. And then model versioning tends to be critical because now you're also probably, it says here, 50% of the people have probably 15 iterations or less when they're developing a model. So do the math. If you have 10 models in production, you're replacing them every 90 days and it takes you 15 iterations. You're having to keep track of a lot of different variations of models that you're bringing into production. I'm going to go into a demo now. What we're going to do is go into the Kubeflow UI. We're going to talk about how to build a model in a Jupyter Notebook, automate some pipeline building, run that pipeline. And then the tutorial also goes further to where later, if you wanted to go back and rebuild the model from a snapshot and run it with a data set, you could do that. In this particular Truth in Advertising, this is from Aricto. I put at 7:02 today, I put the links to these tutorials, as well as Aricto's new Kubeflow as a service offer that just came out yesterday. I just started using it. Truth in Advertising, I was Aricto's first employee in the United States 3 years ago. I don't work for them now, but I still own a lot of stock in the company. So take this with a grain of salt, right? I like to see them succeed, but I do want you to know where I'm coming from. But this is a PyTorch, a distributed PyTorch demonstration. I got a lot of feedback that people would like to see TensorFlow PyTorch types tutorial. So I was pushing the company at the time to move in that way. This uses a data parallel approach, and that has a Kubeflow PyTorch operator with one master pod and at least one worker pod, and training the same model across independent workers on separate data batches, and then aggregates the model weights or gradients using a reduce operator. In the demo, this does use an extension to Kubeflow from Aricto. It's called Kale, and Kale provides a high-level Python API called Distribute. Distribute automates the creation and submission of a PyTorch job custom resource. To use this function, you're going to need a model, a loss function, a data loader, an optimizer, a training function, and an evaluation function. And we're going to build a pipeline that looks like this. We'll go into that in a little bit more detail. And basically what this tool and extension does is it helps you describe and submit the distributed PyTorch job, and it will write the custom CR, which is a YAML file, provides the run configurations and the containers for the pods, right? Builds the Docker image for you, and then make sure that your data can get, you can get to the data that you need to be able to run this. So this is what Kale and Aricto's Rock help to do. Again, this is just an example of what you can do in Kubeflow. I'm not saying that's the only thing. I'm just giving it because it was an easier way for me to kind of demo this. This link kind of shows where you can get started with Kubeflow as a service. You know, this was kind of a nice turn up. The first time I tried to turn it up yesterday, I got a failure message after about 15 minutes, but it does spin up. I think there's about 40 pods that it deploys. And the second time I spun it up, it worked fine. So I was able to get it up, and I'm running this tutorial here. Let me see if I have this easily. Introduction to distributed training, which should be in the list. So this is the Kubeflow tutorial, central dashboard. Actually, this is the notebooks version. But if you go and see the central dashboard that is in Kubeflow as a service, it's a bit of an advertisement for Aricto, but if you just deployed Kubeflow, you would see something sort of similar, except for this middle part's going to be a little different. What's important here is you do have this namespace isolation. In this case, because I'm only having a single namespace, right? But I could have multiple namespaces. I could have one for Dylan and one for Jacob and Jonathan, and they could all be separated, isolated with their own resource limits using Kubernetes. But also we could share namespaces as well. So that's one important thing that Kubeflow has built into it at a foundational level. But on the Kubeflow basis at this central dashboard, and all of these are available through APIs as well. But basically what you've got SDKs, but basically you've got this UI that shows your notebooks, right? And we're going to go into a couple of these notebooks, but you know, I've got a couple of notebooks here, and you've got your name, your type, and your age, the activities, the image that you're using, whether you're using GPUs, CPUs. And some of these are a little messed up here on these announcements. This is some things that Aricto did when you're rebuilding these from a snapshot. So although this looks like a funky number, everything works fine. I've reported that to them, and anyway, you see that number. You also have a place to see all the tensor boards that you have, all the models that you're running in production. This snapshot is, again, a Aricto snapshot store based upon their proprietary storage class that they buy for Kubernetes. In normal Kubeflow, you probably wouldn't see the snapshot store unless another vendor put it in. You have your volume manager. Again, this is all the persistent volumes where you're keeping all your data. Your experiments, this is for your AutoML. If you're familiar with AutoML, you just give it the data set. It'll run it through a bunch of different options and bring you back the framework that might be good for you. You have 4 buttons here to get into into pipelines. We'll go into those here shortly. Experiments, pipelines, runs, and reoccurring runs. So pipelines very important. So the ability to get in and look at your pipelines experiments is important here. I'll just click into that so you can see, here's the pipelines that were some of these were preloaded. This is the one that I built, and we're going to go into the tutorial. And here's some of the runs that I've run already. Reoccurring runs, kind of nice. You could think of, hey, I get new data every day and I need to do a reoccurring run once I cut off my data. That's where the reoccurring run comes in nice. And you have artifact store as well as executions. So that's the central dashboard. In the interest of time, I'm going to move kind of quickly back into the notebooks and just show how to build a notebook kind of quickly inside of here. So I clicked in build a new notebook. You can just give it a name. So you could call this, test or whatever. And you have an option to either use a custom image that you bring in, but you can build, a Jupyter, a VS Code, or RStudio. It comes preloaded with several images that you can use. Here's PyTorch or Jupyter, many of the different ones that you might be able to want. You can set your CPU and your RAM settings. So, maybe I want more CPU than just a half a CPU and more RAM. Maybe I want to use GPUs. You can also set up your workspace volumes. So managing data, as you well know, is important in data science. So the ability to make it easy to be able to get to your different data sets is cool. And this allows you to put a name into it and set up your storage class, what your access mode is, and what your mount path is. You can do the same thing for your data volume. So you have a workspace volume that's directly associated inside of where you're doing all your work. And then, of course, you have data volumes that you can attach in if you have bigger data sets that you may want to share between different users. Configurations give you more options about how you want to set up this notebook, and then affinities and tolerations. You may not want some notebooks, for example, to run on a GPU node because it just doesn't need to. But you can have these tolerations and assign those, and then you hit launch. And when you do, you'll get a notebook that looks like this, right? I've preloaded in already a notebook, and this notebook example really is called Corona Hack. It's from Previn. And basically what this does is the data set of chest X-ray images. And the goal is to look at the X-ray images and to see if the X-ray image is healthy or not. So in this, it's a fairly simple notebook. You've got your imports. One thing I noticed when I was running through this is that this import torch metrics didn't seem to work real well for me. So I had to go back and import that via the terminal. But in the instructions that give you very detailed instructions about how to bring stuff in, you'll see how to bring in this notebook and all the dependencies that may not be in this import statement here. But either way, I just give you a heads up that you might get an error statement on this in import torch metrics, or it may not work for you. If it doesn't, just put in a trouble ticket to Ricto and they'll help you with it. Then you load and pre-process your data, pretty straightforward. You've got your image path, you've got your image size, then you bring a thumbnail out of it. Probably the important things that you're doing in this step is you're cropping the image, you're transforming it, you're converting it to a tensor, right? So now you've got, and I'm not a Python programmer, I'm learning Python, so I'm glad to be here to learn from y'all. But you've got basically this this code here that will allow you to do these transformations, right? And then once we have this, we've got this successful tensor, and then we're able to see that the shape of the tensor is 1 by 24 by 24, which is a single grayscale, single color in here. Now we're ready to load the model that we've trained using the Corona Hack PY. That's this code, this text here, script. And in order to do this in a distributed way, we want to get the model where it's stored. And so this is the syntax or the instructions here. And you'll want to start a new distributed job from this notebook so you won't lose your saved model. And this permits you to work iteratively, as it says. So this is the code that kind of walks you through how to set up that job. You got a job name, a home, a model path, right? And then you have the model defined. And so now we're ready to do some prediction, but the model returns 2 scores. So you're using the softmax layer to be able to get basically to validate the probability between the healthy and the unhealthy class. And now basically you're going to expand the image of the tensor to account for the batch dimensions. So that's this section here. And then you go ahead and do your prediction. But this is shows that it's a healthy example, but it's only for one image, right? And really what we want to do next is calculate the accuracy of the model on a larger data set. So we want to bring in a larger data set and walk through that. And this kind of walks you through how to get that through and set up a data loader. The first thing you have to do is set up this target variable. Hopefully this is large enough. I'm sorry if this was too small and I was going through it, but you can see some of the code here. And the only reason I'm walking through this is because it's really not that long. We're almost through it. But you set up your target variable and you keep only the metadata from the test data set, right? And then you've got basically the core of what we're going to do here is we set up a load data, and then we have our loss and our accuracy metric. And then you can set what device you want to run on, and then we have our evaluation step, and we get your analysis here of loss and accuracy that comes out. So that's kind of the model. Now, what Kubeflow and Kale allow you to do, which is kind of cool, is once I've got to this place where I have a model that's pretty good shape and I want to build a pipeline on it, I have this ability, and I'm showing it from this syntax here, which is this Python 3M Kale Corona hack compile. I'm going to hit return here. Hopefully this will execute for me. Hold on, let me see if I've got some type of, I'll refresh this. All right, let's see if this now. Okay, so now what this is doing in this compile is it's building the YAML file that's necessary to build my Kubeflow pipeline. And I don't have to build any Docker containers. I don't have to write any pipelines DSL code. It's basically understanding what I need to do, and it ran that for me. The next thing that I'm going to do is I'm going to run this pipeline. And so you can see the syntax here where I've got Python 3-m Kale Corona hack pi --KFP for Kubeflow pipeline. And now this is going to take that YAML file and actually run and that pipeline and create it for me. So if I go back into the UI, right, and I go into runs, what you'll see is pretty soon I'll get a new run that shows up here. I've already run this 3 times before, so I'm going to go in and show one that I've run before. But it basically will create this pipeline for me with these 4 steps. First is it starts with this volume. So the data volume allows me to feed in all the data and the hyperparameters and much of the information that I need in each of the steps as I go along. But I define my model, right? And this is really defining the data set, the metadata, and returns the data frame with the metadata and the training test sets. Then I load the data sets in the second step, right? And I have in this area, I'm able to, actually, I got that a little bit backwards. This one is defining the model, that it also defines all the loss, the optimizer, and the model pre-trained the model is pre-trained, excuse me, with ResNet 18. So I got that a little backwards. Here you're loading the data set and the metadata. Here you're defining the model, and then you submit it for training. So it's building a custom resource in Kubernetes and deploying that. And it's doing distributed training on multiple nodes in this step. And then in the monitor step, you can actually monitor it. So if I go in and I look in the logs in the monitor step, I can, if I go back up here, I can see that, here, let me see if I've got here. Yeah, so I can see that I've got these epochs. I know this is a little small, I apologize, but you've got your epoch 2 here coming out, and you've got your loss and your accuracy, and then you've got your epoch 3 and your loss and your accuracy. So you can run through this data set and you can kind of see all the different epochs that you're running through and get results. The goal here was kind of give you a feel of, Kubeflow as a service and kind of this tutorial, how it works. And the fact that you can do this end-to-end workflow and build a pipeline relatively easy. And again, this is all based in what's inside of Kubeflow. So I'm going to move on from the demo and go back into a little bit more about the community and wrap up. I just want to impress upon people that the Kubeflow community now, we're probably getting close to 4 years. We've really developed a way for the users and the working group and the distributions. The distributions you can think of, people like Amazon and Google and IBM and all these other companies that also are involved, whether it's Nutanix or Arista or Cisco or whomever. They support end users that are running Kubeflow in production, and often they pay them for it. And then you have the working groups. These are the open source contributors that build all the different components of Kubeflow that we went over, the notebooks, the hyperparameter tuning, the pipeline. And as this in the release team, basically we work with the users to kind of define when releases will come out. And we have community meetings every week, Tuesdays and Wednesdays. So we have working groups and we have the larger community, and we track everything in GitHub, and we have Kanban boards and Slack questions. I think we have like 7,000 Slack members now. And then we also have an email. So inside of Kubeflow 1.5, which came out in March, just to give you an idea, we have all these milestones and timelines. We track everything in Kanban board. We came out with Kubeflow Pipeline, switched over to the emissary executor. You guys probably saw that in Kubernetes 121, 122, as they're moving away from the Docker. And then you have the hyperparameter leader election. So with HA support, so if a hyperparameter leader fails, it's got a way to recover, validation for early stopping, algorithm settings, elastic training with PyTorch. This allowed you to support spot instances, and notebook idleness monitoring. So I'm running a big notebook, and it's got GPUs on it, and nobody's using it. It will flag it and tag it and shut it down, right, after a certain period of time, and then more options for PVC. So you can see as we're on our 13th, 14th release, Kubeflow 1.5, that we're really getting in, not big, massive changes. We're tweaking at the edges and making things optimized. 1.6, we've got a tracking issue for this. We're just starting on the feature release cycle. We'll do the feature freeze probably next month, I think it is, at week 12. And then, manifest testing starts. We deploy all this using manifest and customize, if you're familiar with those tools. We really try to focus on documentation. Open source documentation is typically pretty bad, and we try to work pretty hard on that. We've raised our scores on that in the release coming out in the 20th. And we also have all the working groups do a presentation to the community and give an update. And here's some of the features that they, I don't know what happened here. I just clicked on the wrong thing. There are some of the features that they talked about. So you can see we have a pretty big pipeline of features that are being developed for July, and the updated DAG visualizations and pipelines and increased UI enhancements for separate pages for trials and trial logs for CATIB, and PyTorch elastic training enhancements, and Volcano if you're MPI version operator 2 for the training operators. Lots of stuff in the notebooks, and in Kserve, the model mesh, so you can do high scaling and get around pod or pod limitations, for example, and being able to use Knative effectively in serverless. So if you want to join, the things I would suggest is, try the Kubeflow Slack. It's, easy to get onto. Try some of these tutorials. If you're using Kubeflow, think about answering some of the questions in the user survey, and you can find the link there. We have lots of people coming in. So that's the Kubeflow start part. The second part that I want to talk to, and for some reason my computer's flipping through things faster than I wanted to, but now I'm on open model risk management. So about 2 months ago, I got together with a professor at NYU and the founder of a startup who works in the model risk space. And we started monitoring what was going on from the Federal Reserve guidelines, SR 11.7. And we talked about, hey, we probably need to give some guidelines or perhaps develop some open source code about how when you're running models in production, how do you collect the information that the Federal Reserve is going to audit you on? And so we started this GitHub space. We have an RFC that talks about how we're going to build this architecture where there's on each model, there's an agent that's collecting information on the model run. And then in a server, it's collecting all those model runs and connecting those model run information with even broader information about how that model was developed, who developed, when it developed, when it was last updated, who authorized it, all the questions that you have get asked by the Federal Reserve. We do community notes, we have a Slack channel. And if we do look at perhaps maybe some of the Slack channel, it's kind of interesting, some of the people that have jumped in. As I mentioned, if I go back up here, you'll see like some of these guys are from JP Morgan or here, this Joe Sabelja, he's from JP Morgan. Daniel Stahl, he's from Regions Bank, if you guys are familiar with that. Vibor is from Citi. I mean, these are pretty heavy hitters showing up within the first 90 days. We also have, guys from Gartner, as well as some VCs that come in and kind of watch this, and a lot of vendors and consultants, whether it's H2O or Fairly or, many, many others. So I encourage you, if you're going to work in the model risk space, in the model development space, is learning what, basically the Federal Reserve talks about in the SR 11 document, this SR 11.7, right? And what a model inventory should include and all the fields that you should be reporting on. We tried to take this and put that into a document of, what are all these fields, rather than just giving people like a vague kind of a identification. We tried to make this into fields, and there were about 20 of them. And then we took that and blew it out a little bit further and tried to give more of a schema type idea. And we came up with a bunch of other ideas, just talking to the community, and probably 45 different fields that we'll be collecting. And then obviously you can run queries or prints reports based upon doing these types of, once you have all the documentation or all the data, you can move forward with that. So I know I covered a lot. Maybe I'll stop here.
All right, thanks so much, Josh. It was very interesting. Yeah, so on the it looks to me like the things you're looking for in the OpenMRM, they're applicable to many other areas as well. I don't think. I wonder if you thought about that, because there's. I'm pretty sure everybody kind of wants to know, like, who developed the model and when it was released, and all those fields that I see there. They look very applicable to other areas as well, not just like finance or. So yeah, I wonder if you.
And you're exactly right. I mean, I was surprised. Again, I haven't been pushing it too hard, but you know, just from natural progression of putting the word out that we're building this community. We saw people from healthcare come in. We saw Adidas and Nike. We saw Rakuten. So there is a heavyweight inside of the financial institution, no question already when we're first starting. And we're actively pushing in that space because they're feeling the pain the most, right? But I think you're exactly right. Most of the other, and especially regulated like healthcare, they're trying to get ahead of pending regulation, right? And they want to implement best practices. And, you know, any good management, right, probably is going to be very concerned about this. If you look at the Federal Reserve's guidelines, just to give you, you know, I think I have this somewhere, but that I pulled out the text. It's not right here, but it actually says that, you know, the board of directors of the banks are obligated to make sure that they have good model risk policy practice. And if you look at all the problems that they've run into with bias or gender or ethnic, whatever, that, you know, nationality based, but even on that, just based upon risk. I mean, things that we've seen with coronavirus or with Russia being excluded, there's just a lot of risk if your models aren't robust. So I think you're exactly right. And those lessons apply to many different verticals, not just finance.
Yep. Any other questions for Josh?
We did have another question here in the chat, and I was wondering if Chris Peck would like to unmute and ask himself.
Certainly. So I'm not terribly familiar with a lot of this, but in Kubeflow, at what point when you're actually running those models are we defining like the kind of container that we need in order to scale up and actually, you know, crunch through it? Is it something where it's like there's a setting somewhere where we're saying we need this type of container with these kinds of resources at this point in time, or is it somehow figuring that out for us?
Yeah, I mean, that's an excellent question. And that's exactly what the custom resources and the training operators, for example, or the serving operators are designed to do, right? So there are capabilities that you can put in, say, I want GPUs or CPUs, and I want it to be able to scale up so much. But it's really incumbent upon Kubernetes to go and do that operations for you. So you're not having to go in and find the actual node or server to run it on, right? And that is a huge time savings for most ML teams. So you hit the nail on the head there. There is an ability to use Kubeflow and its natural capabilities, and especially if you're using something like AWS or one of the cloud services, and obviously you want to be able to limit how big they'll grow because you want to limit your expenses. But the other part of it is you do have the ability to go in and tweak those too. So you have the best of both worlds, right? It'll do it for you, but if you want to go back and get into the lower level and deal with the YAML and make some tweaks to it because you need more RAM, you can do that.
Very cool. Thank you.
Great question. And probably way over my technical capabilities. No, just kidding. So it was a lot of fun. I hope you all get a little excited. The Kubeflow as a service is easy to spin up. It does take a little bit, 30 minutes to spin it up. But, you know, to run through some of those tutorials, you can say the first on your block to run a Python distributed job. And, you know, within an hour, you'll be the coolest kid around.
Josh, yeah, I have a question for you. You mentioned AutoML, but kind of skipped it at the beginning.
Yeah.
Can you give examples of what this AutoML can do? And does it require a lot of expertise in machine learning, or just a novice, someone who can just click buttons can use it?
Yeah, well, I think the long-term goal is to click buttons to use it, but basically the hard part with a lot of, and if you look at our surveys, here, let me see if I can pull up, this is the latest survey. These might be interesting to you. You guys aren't supposed to be seeing this, but I'm showing it to you anyway. This is the survey information that's coming out from the, you know, what frameworks people are looking for. And I think this is relevant, you know, PyTorch and TensorFlow tend to be the most popular. But back to the question that you had, what I was really trying to get to is where people have most of their problem. A lot of it is connecting their data pipeline to their machine learning pipelines. You know, a lot of people don't have this like problem. You know, we study a lot of the problems where people have their biggest gaps and things, but a lot of it is I've got to get my data set right. And then I can just take that data set and either I'll use my knowledge of I'll try PyTorch, I'll try TensorFlow, I'll try XGBoost and MXNet, whatever, you know, whatever it is, right? Or I can hand it off to this AutoML component inside of Kubeflow, and it will run through all these analysis. And there's a tutorial to do this that you can run through. And it will show you how the AutoML kind of goes and tries different frameworks and then comes back and picks the best one for you and says, here, I think this is the one that will, and so that saves you a little bit of time, because how much of, at first, you know, everybody loves to do a lot of experimentation, but when you're really under the gun and you need to be able to deliver it fast, and maybe you can just go and run this on a Thursday night and have the results Friday morning and say, yeah, we tried 15 different frameworks and this is the one that we think is the place where we should spend more time. I think that's where AutoML is going to be valuable for the more mature.
Yeah, it looks like a cool feature.
Yeah, the folks from Janu from Nutanix and Andre from Apple have spent a lot of time in both those spaces. And, you know, we are definitely looking for folks that can exercise all the new features that they put in. And, you know, let's face it, every software developer, that's their goal, is to get people to use their code, right? So that's why I'm Johnny Appleseed out here trying to, you know, get people fired up, if that makes sense.
Yeah, I have another question about the OpenMRM community.
Sure.
So, who can join? What do you actually look for people when joining? Like, what do you see and what activities do they do?
So I'll put this Slack thread or anybody. We allow everybody, even you. So we definitely encourage as many people to come in and provide comments and just listen to what we're trying to, the types of problems that we're trying to solve. We definitely have seen people come in with new perspectives and post things in the Slack channel, for instance, and say, hey, you should think about this or that. I'm currently starting to work on, you know, some of the code for the model agent right now. And I could use some Python expertise on how to capture some of these artifacts inside of a model, because, you know, getting the timestamp of when it started and some of these things not as complicated, or developing a model run ID, you know, via an increment counter, maybe not that hard, but making sure that you're getting all the outputs and all the inputs, and how far do you go on that? Do you get all the hyperparameters? Do you get the Docker image? how much do you collect in terms of the artifacts and the metadata? That is a little vexing to me right now. There's tools out there to do that. Linea is one of those that has developed something like that. You've also got Aricto with Kale. But as we start to look at that, I think that capturing the metadata, all the information around how the model was built is going to be more and more important. So please come and put in comments and bring your Python expertise. It'll help me.
Okay, and the next meeting, you said the date, but is there a link somewhere that people join, or is it like physical meeting, or?
Yeah, it's May 26th. It should be a Thursday. I just set it up today. I'm working with the gal from Honeywell, who is also a co-conspirator, and we're working on the agenda. We're actually going to go over the database schema, both the parent and the child concepts and what types of databases we might put in. So along with that, all these vexing questions that I just talked about, how to build the agent, those are types of topics that we're going to go into in architecture. But you'll see that start to get posted in the Slack channel. And then we have a calendar, which I send out to everybody that's in the Slack community. So join the Slack and you should be able to get information on when that comes up, or I can send it out to you guys once I get everything set.
Perfect. Thank you.
Yeah, it's kind of like flying an airplane, fixing it, and building it all at the same time. And it's super complicated, but it's a lot of fun. Thanks for the time to speak with you, and I hope that you can use Jonathan's example in the chickens and the robots. Maybe you can run that in a notebook inside of Kubeflow as a service, and you can get 2 for 1 out of these 2 presentations today, right?
Awesome. Well, thank you so much, Josh. This was a great talks and very interesting. And yeah, please do join the Slack channel if you're interested. I'll take a look in there. I think there's potential for probably some other uses for this. So I'll take a look at this.
Yes.
Thank you. Thanks so much. Really appreciate it.
Thank you all.